In this lesson, we are going to look at an alternative method to graphing systems of linear equations. And this method is solving by substitution. The graphing method you learned is time-consuming, and you can only approximate the solution unless you are using technology. We use algebra to determine an exact solution. One algebraic strategy is called solving by substitution. By using substitution, we transform a system of two linear equations into a single equation in one variable. Then we use what we know about solving linear equations to determine the value of that variable. This skill is used regularly in math and science. So the substitution strategy you will see often in math and science in a variety of different applications. So here are a couple of examples. In this first one, we want to solve the system 2x plus y equals 11 and x equals 13 plus y. Now, ideally in substitution, we would like to not work with fractions, if at all possible. What you want to do is you want to make one of the variables in one of the equations to be isolated. Now, in this first system, we already have the x isolated in the second equation. So we don't have to worry about manipulating either of the equations to isolate a variable. We can work right from here. What we have, x is equal to 13 plus y. In this system, when we are looking for the solution xy, x is the same value in both equations. So what we can do is we can take this x value and we can substitute it into the x value of the second equation. So if I rewrite 2x plus y equals 11, what we are going to do is we are going to replace the x with 13 plus y. And then we have plus y equals 11. So notice the x. So we have replaced the x with 13 plus y. Notice there is only y's now in that equation, and that is very important. If you still have an x and a y, then you have done something incorrect. You only want there to be one variable, because now we can solve for the variable y. So we distribute 2 through the brackets, and we will get 26 plus 2y plus y equals 11. We can combine our y's. 26 plus 3y equals 11. Now, solve for y. Subtract 26, and we will have 3y equals negative 15. Divide by 3, so y equals negative 5. So what we've done now is we've found the value of y. What we now need to do is we now need to find the value of x, and we are going to do substitution again. This time, though, we are going to replace a y value with negative 5. We can go back and we can use either of the two original equations. It doesn't matter. You will get the same answer no matter which you choose. However, the second equation would be the easier one to use because the x value is already isolated. But you could use the first equation and get the correct answer. So we have x equals 13 plus y. So we substitute the negative 5 into the y spot, and then we do 13 subtract 5 is 8. So our solution is always x then y, so 8, negative 5. And you need to actually write the coordinates as your final solution. If you are using something other than x and y, go in alphabetical order. So if there was a's and b's in the question, put it a, comma, b. If it was m and n, go m, comma, n. So that's substitution. Let's look at the second example. In this one here, none of the variables are isolated right off the bat. So we need to isolate one of them. Now there is an efficient strategy. If at all possible, look for a variable that has a coefficient of 1 or -1. And if you have a variable with a coefficient of 1 or -1, that is what you are going to isolate. Otherwise, you may end up dealing with fraction values throughout your question, and it just makes it more complicated. It's not that it can't be done, it's just more complicated. So in this one here, this variable y in that second equation has a coefficient of +1. So that's the variable we are going to isolate. So we need to subtract 4x from both sides, and we will have y equals -4x plus 5. So now what we are going to do is we are going to take this -4x plus 5, and we are going to substitute it into the y spot of the other equation. And very important that you put it into the other equation. You cannot substitute it back into the equation that you manipulated. So I'm going to rewrite 2x minus 4y equals 7. And we are going to replace the y with -4x plus 5. Notice the y is not there. That is a common mistake. People want to still leave the y somewhere. No, we've substituted a value into the y spot. Now we can distribute the -4 through the bracket. So we'll have 2x plus 16x minus 20 equals 7. We can put our x's together. We can add the 20. And then we can divide by 18. Now, you're not going to get a whole number. Here's a little rule to follow. If that value is a terminating decimal, 27 divided by 18 is terminating, you can choose to write it in decimal form because it is an exact value. But if it was repeating or if it continued on, you would have to leave it in fraction form. Remember, algebraic methods are not approximations. They need to be exact values. So in this case, 1.5 is terminating, so we can use 1.5. But if it was a repeating or a non-terminating decimal, you would have to leave it in fraction form. And now from here, so we have our x value. Now we need to find our y value. So we go back to one of our original two equations. Doesn't matter which one. I will choose to use the second one. 4x plus y equals 5. Now what we are going to do is we are going to substitute x as 1.5. Notice the x value is now gone. So now 4 times 1.5 is 6. We need to subtract 6. So we'll get y equals -1. So our solution was 1.5 -1 or 3/2 and -1, depending upon whether you want to leave it in decimal or fraction form. We can solve equations that have fractions as their coefficients. But we can do in one step, we can make this a little bit more basic. What we want to do is we want to eliminate the fractions. If you look at the first equation, 1/3 x minus 3/8 y equals 1. Think back to when we were solving equations and how can you eliminate fractions? Hopefully you remember that you multiply every term by the lowest common multiple, or the common denominator. So in this case, we can multiply every term by 24. And it's important that you multiply every term by 24. 24 times 1/3 is 8x. 24 times 3/8. 24 divided by 8 is 3. 3 times 3 is 9. So minus 9y equals 24. Now you look at the second equation. Same thing. We are going to multiply every term by 24 because that is your lowest common multiple of 4, 8, and 2. 24 times negative 1/4 is negative 6x. 24 times negative 1/8 is negative 3y. And 24 times 3 over 2, 24 divided by 2 is 12. 12 times 3 is 36. So here are our two equations. Now, unfortunately, none of the variables have a coefficient of 1 or negative 1. So we are going to be dealing with fractions here. And I'm just going to do this one to show you that it can be done using fractions. However, in the next lesson, you are going to learn another algebraic method that is a lot more efficient for a question like this. So let's pick the second one here, and let's isolate the y. And the reason why I chose this one is because all of these values are multiples of 3. So I might be able to eliminate the possibility of dealing with fractions. Whereas if you look in the first equation, they are not all multiples of the same value, so you would be guaranteed that you would be dealing with a fraction. So here, I'm going to add 6x. I'm going to have minus 3y equals 6x plus 36. Then I'm going to divide by minus 3. I'm going to have y equals negative 2x minus 12. So we aren't going to have to worry about fractions. Take our minus 2x minus 12, substitute into the y spot of the other equation. So we'll have 8x minus 9 times negative 2x minus 12 equals 24. Distribute the minus 9 through the brackets. We'll have plus 18x plus 108 equals 24. Put the x's together. We'll have 26x plus 108 equals 24. Subtract the 108. So we'll have 26x equals negative 84. And in this case, when we divide by 26, we do not get an exact decimal. So we are going to have to leave it in fraction form. And that is negative 42 over 13. All right, so we must leave the answer in fraction form. Now what we are going to do is we are going to substitute this back into one of the equations. Now it technically doesn't matter which equation or which form of the equation you use. We generally go back to one of the original because in an original equation, you wouldn't have made a mistake. Sometimes when you manipulate an equation, you may have made a mistake. So now you're going to be making a mistake again because you already had one. However, if we go back to an original question here, equation, we have fractional coefficients. So we're going to use one of the equations that we did some manipulating on. And this one here would be the easiest one to use. But it doesn't matter, we could have used any of the equations. So we are going to substitute negative 42 over 13 into the x value. This is the same as negative 2 over 1. So what we'll have is 84 over 13 minus 12 over 1. You can either use your ABC button at this point in math, I don't care how you deal with fractions, or we can find common denominators. So we would times each of these by 13. And we will have 84 13ths minus 156 13ths And then 84 minus 156 is negative 72/13. So our solution, negative 42/13 and negative 72/13. And that is an exact value. So that is your substitution method. Quick review. Isolate a variable. Isolate a variable. Substitute it into that variable spot in the other equation. Then simplify it up. Find the first variable. And then once you have your first value, substitute it back into any of the original or manipulated equations. So that's what we did right here. And then solve for the second variable. Be sure to write your answer as a solution of a set of ordered pairs.